This is the Earth Science Classroom. This is the Rocks Cycle Part 2 video. This is in the Rocks playlist and geomorphology, and looking at a detailed view of a certain part of the rock cycle, and we're going to connect it up to other parts as a whole and discuss both magma and lava and the composition, the material, and the processes that happen to this liquid material and how it turns into igneous rock as the first main rock type, and discuss those processes and locations on the Earth. So looking at the cycle as a whole, so right here we have the rock cycle. And this video is going to look at the magma and lava element component, and this obviously this lovely arrow, this process forming igneous rocks. So this video is going to look at these two components. Alright, so let's begin. We have this focused in view of the rock cycle where we have magma, lava, and this beautiful arrow going to the igneous rocks. And so basically what's going on? So let's first define this right here. So let's define magma. So magma is a mixture of melt, which is the liquid, basically compositional component of the magma, at obviously certain temperatures, and these range from around 650 to 700 degrees Celsius up to 1350 up to maybe even as hot as 1,500 degrees Celsius. But within that range temperatures you do have the magma being created, and obviously at certain depths, because magma is or occurs underground at certain depths. Now the depth is proportionate to the temperature and the pressure gradient within the crust, within the lithosphere, and even within the asthenosphere, where you do get the convection currents and the magma upwelling to create the tectonics on the surface. But the depth is very important, obviously the temperature, which would define the magma's composition, and if there is what's called fractional crystallization and also mixing. So I do go in more detail on magma in a different video, so please check that out. The link is in the top right. And then lava would be, magma would have the volatiles. So the dissolved gases that would be trapped inside the magma, and again this would dictate how much of the magma is going to stay melt, or how much is going to crystallize and turn into a solid. And the gases, obviously water vapor is a large component of that gas. And magma, the location is going to be obviously underground, under the surface. All right, and if it does come to the surface, then we deem it lava. The term is lava. Now, this is obviously volcanic in nature, and the magma would be plutonic, which is defined by underground. So the lava is going to have a very similar chemical and physical composition to magma. However, there's slight differences between them. Now, in most textbooks, it may say that it's just the location, that lava is on the surface, flowing out of volcanoes, or fissures, or cracks in the earth, and magma is just underneath, prior to erupting. However, because of the temperature and pressure differences between the underground environment and the above ground environment in the atmosphere, you do get slight differences and slight changes in the composition of lava compared to magma. So we have these liquid materials born from the environment underground being hot enough to melt some rock. Now, some rocks don't melt. It's not like completely magma underground. There is a large solid component to the Earth's crust, obviously. Around 1 to 5% is going to be melted. So it's not a large proportion of magma compared to the solid crust, but is enough to obviously discuss in great detail for things like geology and volcanology. So as this liquid material increases goes closer to the surface or decreases in depth. So there's a decrease in depth. Now this magma, the magma could or will stay underground, but it's going to cool slowly. So the magma is going to cool slowly. And in comparison, the lava, as it is erupted out of a volcano of some sort or different types, the lava is going to cool quickly. Very suddenly. The magma could cool over the course of thousands of years, very slowly cooling down. The lava could cool in a matter of seconds. Depends on the eruption type and the amount of lava and the environment it comes into. So right there, with the speed of cooling, we have what's called crystallization. When it has ation at the end of any kind of word in science, it means the process of the going to change into something. So in terms of, when you hear crystals, in terms of geology, think solid material. So the minerals that are inside the magma or lava as part of the composition, the minerals, which are obviously in liquid form, they're going to crystallize and turn into solid minerals with a defined chemical and physical structure that are naturally occurring. So it's a certain structure that these minerals form. Each mineral has a certain structure. So when these minerals combine, they form definitive structures, which then would lead to the rocks that contain these minerals having their own composition, their own structure, and their own characteristics based on what minerals are inside. So crystallization is the process of making that liquid melt, that liquid minerals into solid structures, and also a lattice or a matrix. So you have this, and then you also have what's called consolidation. Consolidation, again, is the con means with solid, and ation means the process of. So making a solid material from a liquid material. So you're going through a phase change. If you are chemistry enthusiasts, a phase change. The actual magma or lava is freezing. Technically freezing. Now you think of freezing, you think of 32 degrees Fahrenheit or 0 degrees centigrade, but because these minerals that are inside the lava or magma, they have different or varying freezing points where they would change the state of matter from a liquid to a solid, the magma would again have a range of temperatures whereby you would have crystallization and consolidation happen within the magma to form these igneous rocks. So again, the temperatures can range from between 650 degrees up to around 1350 degrees Celsius. Okay, so once this happens, once you get crystallization and consolidation, you will form a solid piece of rock that we call igneous. Now, there are different types of igneous rocks. So types of igneous. So you have extrusive and you have intrusive. Now, extrusive is called volcanic, as I mentioned earlier, and intrusive is plutonic. So it is referring to the location of where the magma or lava is going to start to cool down. The lava is extrusive through volcanoes, and the magma is going to be intrusive, so inside the ground. So again, the speed of cooling, and that's going to change the crystal size. The longer the magma has to cool down, the larger the crystal size, and the more mixing occurs within the Earth. So the more mixing, so you get more of a larger number of minerals in the igneous rock if it is more intrusive compared to extrusive, which has less minerals and less grainy texture and appears to be more of a solid color. Again, I do more detail into the igneous rock types and how they form in a different video. So just for the extent for the rock cycle, we can discuss the types, the locations, is it going to be above ground or underground based on the surface, and you can also discuss the common rock types you might find, like granite or granitic rocks, or some basalt. Again, these come from the 4 main types of magma, which is going to be pyrrhotite, basaltic, all right, granitic, and the last one I can't fit in is andesitic. And these refer to either it's going to be felsic magma, intermediate magma, or mafic or mafic magma, and that depends on the silica content, and that would define the viscosity, the temperature, and the gas content, and that is the 4 types of magma, and they transfer and consolidate, crystallize into igneous rocks based on location, whether it's intrusive or extrusive, and you'd have definitive characteristics for either type, and that's part 2. Thanks.